of the alternating current and alternating voltage. Okay, so now see what the thing is that suppose I'm just going to write a alternating whenever the voltage is going to change with the time. Let us see, just like see, I can have a change of voltage with time. I can write like this way. This is the voltage, this is the time. I can have like this. The voltage is changing with the time. Again, it is just going to come down. Again, it will rise, it will come down. This kind of shape, it is possible. Okay, but sometimes we can have like this kind of shape. The voltage, this is the time. Just like this, the voltage is constant. This part. Again another part. Again another part. So this kind of shape is possible whenever the voltage is changing. But I can have a like the voltage and time like this way, like sinusoidal shape. It is possible. It is possible. There's a voltage and time. I can, so in a different shape, so voltage can be a mathematical function of the time. We can just express. Okay, so it is a straight line. Some part is a straight line. This is rising and it is coming down. Again rising, it is coming down. This kind of shape. Here I'm just going to observe that this voltage is just like, see, some part is constant, this part is zero, this part is constant, this part is zero. This is the way that the voltage is going to come. Here it is a sinusoidal form. So in this way, the lot of the voltage shape is possible. We can create that kind of source of the voltage. That is possible. Okay. Now see, whenever this kind of voltage is going to come, which is going to change with the time, most of the cases what we do, we take an average voltage. Just like, let us start with this part. Just like see, this sinusoidal shape. What kind of shape? Vt, sinusoidal shape. Voltage. Okay. Now see, this is a peak voltage, the maximum voltage. Let us think this is a V naught. And we can write the expression of the voltage like V, just like in a wave like of shape, V naught sine omega t. Simple. It is oscillating, just like what we have done in the simple harmonic motion wave, wave and simple harmonic motion in the. So it is a SHM equation. You can see it is a voltage. Sometimes it is going to become maximum. Again, it is coming down. Again, it is in the opposite direction. It has become opposite, negative V naught. It is a plus, it is a minus. Again, it is going to become zero. In this way, the oscillation is going on. The voltage is going to oscillate plus minus, sinusoidal is occurring. Okay. So omega is what? Angular frequency. We know the omega is equal to 2 pi f, or omega is equal to 2 pi divided by time period. That we know. Angular frequency, which is related to the normal frequency. F is the frequency. What is that frequency? Is number of oscillation per second. This f is the number of oscillation per second. Okay, and t is the time period. One complete oscillation requires some time. That time is t. This t time period. Okay, fine. Now see, whenever this kind of up down, that voltage when changes, we require some average value of the voltage. So what I can do, you can see one complete when one complete oscillation occurs, we can observe this is the total time period from here to here, full time period t. Naturally, this portion is t by 4 at this point, t by 2 at this point, 3t by 4, and this is a full t. Whenever t by 4 is going to come, the voltage has become maximum. Whenever t by 2, it is just reduced and it is becoming 0. Whenever 3t by 4, it is going in the opposite direction and becoming maximum in the opposite direction. And whenever it is t, it is becoming 0. This is happening. So now, if I just going to observe, I have to just going to get an average voltage in the duration of the time t by 2. So what to do? Actually, V is a mathematical function of time, ft. Just we can observe that. V is a mathematical function of time. Simple thing. Okay, so what is the expression? We know this thing, V naught sine omega t. So if I just any mathematical function, whenever the voltages I'm going to express as a mathematical function of time, any mathematical function, if I want to get an average, like see this, you have to know, just like see, this is y, this is x, this is a graph, let's think, and the graph having a limit x1 to x2, this is x1 to the in this region. Okay, so if I want to get the average value of the y, what to do? We have to do y average is equal to integration y dx from x1 to x2 divided by integration dx from where? From x1 to x2. Simple thing. This is the average value. You have to remember the mathematical function. Y is the mathematical function of x. Okay, so you have to integrate with x and just give the limit. What is the limit? Lower limit x1, upper limit x2, and similarly divided by limit x1 to x2, integration dx. This is the procedure, how to proceed. I think you understand. Okay, now see what to do from here. This is not important, as I'm just going to eliminate this part. Now we want to find it here. We want to find average value of this voltage within the 0 to t. So how to do that thing? Integration v dt divided by integration dt 0 to t by 2, 0 to t by 2. Okay, no problem. Acha, v, what is the v? Is equal to v naught sine omega t. The numerator part, this is the v average in between the time 0 to t by 2. That's why. So just the numerator part, integration, what is the v? V naught sine omega t, v naught sine omega t dt 0 to t by 2. Okay, then v naught is going to come out. Integration sine omega t. Okay, integration sine omega t dt. So what the result is going to come? If I'm just going to do the integration, what the result is going to come? So minus cos. Minus cos omega t by omega. Just like this one. Okay. So now I'm just going to put that 0 to by 2 is the limit. 0 to t by 2. So finally, what we can get from here, we can write like this way. V naught by omega, this minus I'm going to put outside. Now this cos omega t, cos omega into this value, omega into t by 2, upper limit minus cos 0. I'm just going to put the t is equal to 0, that cos 0. Check. Okay, no problem. Cos 0 means what? Cos 0 is 1. And omega t, you can observe omega t is what? Actually t into omega, capital T multiplied by this is a 2 pi, isn't it? And so therefore I can just conclude that omega t is equal to 2 pi. Therefore that omega t by 2 is equal to pi. So here we can just put it here minus v naught by omega cos pi minus cos 0. Tick. Understanding my point? So therefore what? So cos pi koto? Minus 1. Eta koto? Eta plus 1. Cos 0 mane plus 1. So minus 1 minus of plus 1. So minus 1 minus 1 minus 2. Understanding? So minus 2 into minus of v naught by omega. Therefore the result is going to come, the numerator part is going to come minus v naught by omega into minus 2. Therefore the 2 v naught divided by omega. So instead of omega, what we can write it here? 2 pi by, sorry, 2 v naught by omega মানে হচ্ছে 2 pi divided by t. ঠিক আছে? Understanding my point? So this 2 is going to get this 2 getting cancelled. So the V naught T by pi. Okay. This is the numerator part I have just defined. So now, and if a denominator part, if I just do, what the result is going to come, you can see integration dt 0 to t by 2, limit 0 to t by 2. So final result is going to come t by 2. So the here V naught t divided by pi divided by t by 2 and into 2 by t, then t getting cancelled. The result is going to come 2 V naught by pi. I think you are going to getting answer. So within the half of this period, this is the average of voltage is possible. Within a half of the period, this is the average voltage I can just calculate. I can have. Okay. Now see, if I just want to get the within the period, the total time period, if I want to get the average, the simple logic you can apply. You can see that it is a symmetrical now. This shape of the graph is symmetrical. What is the portion of the upper portion is the positive side, the same amount is the negative side is going to exist. Now, so if I just going to integrate integration VDT within a full time period, if a positive V is there, the negative V is also there, isn't it? This positive maximum V naught plus, the negative also is existing. So if I'm just going to integrate money key is a summation on the positive and negative. The simple summation is going to reveal the 0. Therefore, within a full time period, if I'm just going to do the integration, the result is going to come 0. Therefore, that average value for this kind of sinusoidal expression, average value 0 within a full time period. But I can get for the half time period, I can get the average value. I think it is clear, children. It is clear. Okay, fine, very good. Now see. You can see that we have got an expression of the average value. So now, and also have got that expression of the average value for one full time period is equal to 0. So now we have to do something now. We have to get some solution so that we can get an average. If I just want to find within a total time period, isn't it? Okay, so that the solution is that VRMS মানে root mean square voltage. RMS voltage, but root mean square voltage. That's a simple thing. I have to find that thing. Okay, now see what is this thing actually? A root mean square. The voltage is there. Alternating voltage V is equal to V naught sine of omega t. No problem. Very good. Okay. Now, if I want to get the root mean square, what to do? We first of all do the square. What is the square? V square. Money V naught square sine square omega t. No problem. Very good. It's making the square. And after that, what to do? We will integrate this thing with respect to the time, because this is also a function of time. Yeah, because the time is there, we are just going to integrate. Okay. So now what to do actually? Expression of the VRMS is equal to V naught square sine square omega t dt integration 0 to t within a full time period. Within a full time period, because previously for the average value, well, it is not possible for us to get a within a full time period, it has become the 0. But here, because why it will not become 0? Because the some plus portion, just like see, some plus portion, if something plus is there, positive value of the voltage is there. If I make the square, it is a positive. If some negative value is there, if I make the square, it is again becoming positive. Simple. Okay. So this is the advantage we have for making the square. This is the advantage. So now we have made the square. Again, just we are going to divide integration dt 0 to t. Now, since this is the square term is existing there, if I want to make the root, then the root mean square is going to come. So ultimately, we have to make the square root of the total expression. তাহলে v naught sin square omega t dt integration 0 to t divided by integration dt 0 to t whole root. Simple thing, nothing extra. That is the definition of the VRMS. In the simple manner, IRMS can be defined. IRMS, what to do? Just simply replace this V naught instead of I naught, just like current expression, sinusoidal current, I naught sin omega t. Same thing. Okay. So now if I want to find the VRMS in this way, so we have to going to do the numerator part first. So how to do the numerator? You see, numerator part is integration V naught square sin square omega t dt 0 to t. It is going to become V naught square integration. So let's see the integration sin square omega t dt. If I just want to do this integration, I'm just going to put it half here. I'm going to put a 2 sin square omega t dt. Check. So 2 sin square omega t. What is the relation? What is the final formula? 1 minus 2 sin square theta mane 1 minus cos 2 theta. The same formula I'm going to use it here. So V naught square divided by 2 integration 1 minus cos 2 omega t dt. Simple. So now the result is going to come like this way. Let us see. V naught square by 2 integration dt 0 to t. Here also the limits is at 0 to t, and here minus V naught square by 2 cos 2 omega t dt. Okay, integration 0 to t. Fine. ঠিক আছে. So now let us see V naught square by 2 integration dt, and you can see this part, just like see this part V naught square by 2 cos 2 omega t dt 0 to t. This part actually it is a sinusoidal. This is also sinusoidal. This is a complete periodic expression. So if I within a full time period, if I just do the summation integration, what it will give? Just like previously, it will give the 0 na. The cos is also complete symmetrical with respect to the time axis, just like the sine. It is symmetrical up and down. So naturally, within a full time period, if they do the summation, it will give the 0. So this part is ultimately is going to become 0. So what the remaining portion is there? The remaining portion is that V naught square by 2 integration dt 0 to t. Okay, and so ultimately the numerator part is this one divided by, so denominator part integration dt 0 to t, isn't it? So integration dt 0 to t, integration dt 0 to t, these two parts are going to get cancelled, and we have to finally do the square root. Because we have to find the RMS, VRMS. So this part is going to get cancelled. The root of the V naught square by 2. So finally V naught by root 2. So we can conclude that the VRMS is equal to V naught divided by root 2. Simple thing. The similar way we can conclude that IRMS is equal to I naught by root 2. So if we are going to ask find the RMS value of some voltage, sinusoidal voltage or sinusoidal current, just we have to just divide the peak voltage or peak current divided by root 2. Simple. We are going to divide the peak voltage or peak current divided by root 2. Then we are going to get the RMS value either by voltage or either current. Children, I think it is clear. Okay, I think this one is clear to you. This RMS voltage, RMS current. Okay, no problem. Very nice. Now see, we are going to find some expressions like the applications here. We are going to find some applications of the RMS of the RMS and some application of voltage. Let us see how to just find. Let us think, yes, I'm going to have a current like expression I1 sin cos omega t, I2 sin omega t. Let's, I'm having an expression I is equal to I1 sin omega t plus I2 cos omega t. We have to find RMS voltage current of this expression. Okay, I1 sin omega t plus I2 cos omega t. If this kind of expression comes, then what to do from here, like this one. So you have to first simplify, because you can see that these two currents are just superimposed, just overlapped, two currents. Okay, so what to do, first of all, if it's going to simplify, I have to just make it a simple one single current. So what to do, let us think that I1 let I1 is equal to I naught cos theta. It is a way I am just going to tell. This is a special way how to simplify this expression in a one single expression, to make it one single expression. I2 is equal to I naught sin theta. Just we are assuming something. Okay, so now these expressions can become I is equal to, instead of I1 I can put this one here, I naught sin omega t cos theta plus then I2, instead of I2 just I'm going to put I naught sin theta cos omega t. Okay, very good. So now I'm just going to take the common I naught. What the result is going to come inside? Sin omega t cos theta plus cos omega t sin theta. Very good. So now sin a cos b cos a sin b. So what the result is going to come? Like this way, isn't it? This is the final current expression, isn't it? Just we can observe that I naught is a special thing. I naught is the amplitude here. I naught is the amplitude I'm going to have. So now, how to find the I naught from these expressions? Now see what to do from here. If I want to find the I naught, because I naught is unknown here. What is the known? I1 and I2 is known. So from these two terms, I1 and I2, I'm just going to find the I naught. Simple thing. So now if I just make the square, I1 square, what is the I'm going to get? I naught square cos square theta, isn't it? I2 square, I naught square sin square theta. Then just I1 square is equal to I naught square cos square theta, I2 square, I naught square sin square theta. If I'm just going to add these two, what the result is going to come? I1 square plus I2 square. Yeah. So I naught square, if I just taking common, sin square theta plus cos square theta is 1. So I can write it like this way, I naught square. So I naught expression is going to become root over of I1 square plus I2 square. So children, I think you're getting. Yeah, I think you're just going to getting. So instead of I naught, I'm just going to replacing this one with the root over of I naught, I1 square plus I2 square. Just replace. I is equal to root over of I1 square plus I2 square into sin omega t plus theta. ঠিক আছে? So now the expression of the RMS value of this current, we have got the peak value, the maximum current. So now I'm just going to divide by root 2, isn't it? That should be the RMS current. So now we can have like this way, IRMS is equal to root over I1 square plus I2 square divided by root 2. But simply I can write like this way, everything inside a root I1 square plus I2 square divided by 2. This is the expression IRMS. I think children, everyone getting this point. Okay, no problem. IRMS for this kind of expression. If this kind of expressions come, this is the way we have to find the RMS value. Okay, fine, very good. Now, see, if this kind of expression like I'm going to have an time and this voltage, I'm going to have a voltage. Saying this constant voltage is existing somewhere else, and variable voltage is also existing. P is equal to B sine omega t. Two voltages are there, one constant voltage and one variable voltage. Okay, which you can think it is a current also, just like if I'm going to replace this one, same thing, there is no change, is there? No change. If I'm going to take the current I, let's think the I1 is a constant part, is the I2 is a variable part, two part, and these two voltage currents are just going to overlap, superimpose. So ultimately, what is the RMS of this combination? Okay, so now what to do? Same thing, just like previous one. What to do? If the combination I is equal to I1 plus I2, so A plus B sine of omega t, this is the combined current. Okay, so naturally you can observe this is a function of time, mathematical function of time. This is a time function, omega t. Check, fine, no problem. Now, what thing is going to happen here? You can see that if this A is like this one, this is the length A current, and another this alternating B is like this one. This is a B, this length is B, this is B sine omega t, like this one. This so the magnitude of the A is quite sufficiently enough with respect to this B. Okay, bigger, no problem. So now ultimately, if I just want to find the RMS of this combination of this current, so what to do? Integration I square dt 0 to t. Okay, no problem. Integration dt 0 to t. Okay, whole root this is the expressions we have to find. Okay, so now instead of just one I square, we are going to put the numerator. First of all, I'm going to find numerator. What is the thing? I square. So integration 0 to t, what should be the value of this I square? A plus B sine omega t. A plus B sine omega t square dt. Okay, no problem. So now what the result is going to come, just break it in square. Just break the square. A square plus B square sine square omega t plus 2ab sine omega t dt. Okay, integration 0 to t. Okay, now I'm going to do this integration. I'm going to do this integration since this part is a square dt 0 to t, this part is b square, it is going to come out the constant part 0 to t sine square omega t. Okay, dt plus 2ab is a constant part, it is going to come out integration sine omega t dt 0 to t. This is the thing, it's just the numerator portion, the numerator portion. Okay, Fine. So if I want to do this integration, you can see that if I just separately do this sine square omega t, what to do? Just like previous one. Just like previous one, it was if I'm going to here the integration b square, I'm going to put a half here, 2 sine square omega t, 1 minus cos 2 omega t. Just like see dt, you can see that like b square. I'm just going to put a 2 here. I'm just going to put a 2. So what 2 sine square omega t means what? 1 minus cos 2 omega t. 1 minus cos 2 omega t. Yeah. So if I'm just going to integrate b square by 2 integration dt 0 to t minus b square by 2 integration cos 2 omega t dt 0 to t, just like previous one, this cos part is going to become 0. It is a symmetrical, cos is a symmetrical function with respect to time axis. Within a total time period, the total summation is going to become 0. So this thing I need not require to think about. This part I need not require to think about. This is going to become 0. Similarly, sine. This is the integration sine omega t. Like previous one. Full symmetrical function with respect to the time axis. So within a full time period, it is going to become 0. We have already just discussed that. So this part is going to become 0. So what the remaining part is going to occur? What the remaining part is going to exist here? This part is not remaining. So what the remaining part? The remaining part is just like we can write it here, a square integration dt minus t plus this part, only this part, b square by 2 into 0 to t. B square by 2 t. Bas. So just we have done the numerator portion integration, numerator portion. Okay. So now the denominator portion integration dt 0 to t, only simple t. So now finally we can write like this way, root over of that if I'm going to take the t common from here, a square plus b square by 2, and the denominator part it is also t, just like if you do the integration 0 to dt 0 to t, I'm going to put the t, so t going to get cancelled out, and remaining it is that a square plus b square by 2 whole to the power half. So if this kind of combination of the two current is going to exist, we can have like a we can have this kind of expressions of RMS. Expression combination of one constant current, one variable current, one variable sinusoidal current. So we can have like this, a square plus b square by 2 whole to the power half. This is the RMS current of this combination. Okay, very good. Now see, I think it is clear to everybody. Now, just like our expression, like we can have like different shape can come because in the JE or NEET or mains or JE advanced, whatever, different shapes. Suppose I'm going to have a current, I'm going to have a time. Okay, suppose I can have like this kind of shape. Suppose it is a part of the circle. Okay, let us think, if I continue the circle, it should be like this. Okay, like this one. So I'm going to have the radius is a. We're just going to think. Okay, so now what the thing is going to happen here? I can just keep up for this part, okay, what we can just find from here, the max, this is the any position I square plus t square, we can write a square now, that we can write definitely. Okay, isn't it? Definitely. So I square can be written just like I square can be written the a square minus of t square, isn't it? So if I just want to find that this RMS value of this portion, right? RMS root mean square for this, so for this portion 0 to A portion. So what to do? Integration I square dt 0 to what should be the time? This portion. The time started from 0 and it is a this position, so 0 to a divided by integration dt 0 to a. Check, isn't it? So now I'm going to making the square root. I'm going to make the square root. Fine. Just like every time is going to do the square root of the because the square root is a part, because otherwise I cannot tell it's a RMS value. Root mean square, root is there, root I have to do. Okay, just like we're just going to put the square root, it's also here. So now I square already we have found. What is the I square? A square minus t square. Okay, so now integration we are going to do 0 to a. Instead of I square we are going to put a square minus of t square dt. Okay, so now this a square is going to come out, integration dt 0 to a and minus of t square dt integration 0 to a. Very nice. So now what to result? A square into a minus a square into a into what the result is going to come? T cube by 3, t cube divided by 3. What the limit is there? 0 to a. So finally we can conclude a cube minus this is, I'm going to put the maximum value t, instead of t I'm just going to put the a cube by 3. So 2/3 a cube. Okay, no problem. So now the result is going to come. The numerator part already we have found. What is the numerator part? 2/3 a cube, and the denominator part integration dt 0 to a. We can put a root. So what the result is going to come? The a cube cancelling out, a square minus root over 2/3 a. This is the RMS value of this kind of current. Whenever the current and the time is just mathematically making a circular shape. If I'm just going to draw the graph, then I can have within this period of time, within this portion of time 0 to a, I can have this much of the RMS value. This much of the RMS, isn't it? Understanding my point? Okay, fine. Now see, but the thing is that just another one example I'm just going to do this here, just like previously. Let us think another one. Just there's 3 or 4 discussion. This pattern of question is quite sufficient. So you have to do like this one. You can see like the T and this is the current, and just like this is I naught, and this this portion is t by 4. This part is t by 2. Okay, again down. T by 4, and this is t. This t. Oh, see, if I want to get at this part is t by 4. T by 4. Okay. Now, if it this is I naught maximum, then you can see that the first portion straight line is rising up, again coming down, again going down, again rising. In this way, the some change of the current is going to occur. We can observe from here. Now, see, if I want to get the RMS current within this period t by 0 to t by 4, I want to find the RMS current within the period. Which period? 0 to t by 4. So, what to do? First of all, you can observe that this is a straight line initially. So, you can see that current is equal to something m into t, isn't it? Y is equal to mx plus c. It's a straight line equation, and the line is passing through the origin. That's why I is equal to something proportionality constant into t. M is the slope. Check. So what is the maximum value of I naught? I is equal to I naught. We can put it here, I naught, the slope m. And what is the time at that point? T by 4. There's the t by 4. So m should be 4 I naught by t is equal to the slope. So we can write the equation. I is equal to 4. Instead of m, I'm going to put this value 4 I naught by t, capital T, into t, the variable t, isn't it? This is the expression of the current with the time. Yeah. Okay. So now if I want to find, again like this way, I want to find the RMS current within the time 0 to t by 4. What to do? Same process. Integration I square integration I square dt by integration dt 0 to t. What is the time limit? 0 to t by 4. That we are going to put it later. So now I square, what the I square is? It is a function of time, like this way. I can put that one. Integration 4 I naught by t whole square minus 16 I naught square divided by t square into small t square dt 0 to t by 4. This is the limit, divided by integration dt limit 0 to t by 4. Children, I think you are understanding my point. Everyone understanding? So you have to make it root it. You have to root, square root, whole to the power half, whole to the power half. That you have to find. Okay. So now I'm going to rub this part. Okay. I'm going to rub this part. Now see, the what the thing is going to happen from here. This part, the integration, in the integration, this part is constant. We are going to take out. We are going to take out. It's like 16 I naught square by integration square dt 0 to by 4. Okay. 16 I naught square divided by t t cube by 3, t cube by 3. We are going to put the limit 0 to t by 4. Therefore, it's just like 16 I naught square by t. Just this 3 is going to come out, and I'm going to put the t cube, t by 4 whole cube. That means t cube and 4 into 4 into 4 into 4 into 4 into 4. That's why 4 4 just 16. This 16 is going to get cancelled out, and this t and t cube is going to cancel out. So I naught square into t square divided by 12 into t, because 3 into 4, 12 into t. Okay, the numerator portion, and the you can observe from the denominator portion is equal to integration dt, means only t by 4, 0 to t by 4, so only t by 4. So finally I'm just going to do in the upper portion. So I naught square into t square divided by 12t divided by t by 4, divided by t by 4, one into 4 by t. Okay, into 4 by t divided by t by 4 by t. So what the result is going to come here? This t square, it is going to get cancelled, and the result is going to come I naught square by because 4 and 12 come cutting, I naught square by 3, and I have to make it whole root by root 3. I think children, you are understanding. I naught by root 3 is the part, is the thing we are going to get we are going to get that RMS current for this duration of 0 to t by 4 for this kind of graph, mathematical graph, when the current is dependent. The current is dependent upon the time. Okay. Okay, fine, very good. So this is the things of the RMS value. Just we have discussed that this kind of questions can come. You have to solve this kind of questions. Okay, now see. You can see, children. Suppose I'm going to have a sinusoidal voltage source. V is equal to V naught sine omega t, like this voltage. This is the time and this is the voltage. The voltage is just up down, sinusoidally changing. Okay, this voltage is the maximum V naught. This is the negative V naught. The plus, this is the minus we can have. So now, if I'm just going to connect this source and the source having a symbol, alternating voltage source having a symbol like this one, alternating. Okay, so now just like see, if I'm going to connect this voltage source with a resistance, so we can have a V is equal to V naught sine omega t. The current is flowing through this resistance, isn't it? So now current expressions can be written like this way. Voltage divided by resistance, isn't it? So V naught sine of omega t divided by resistance. Okay, so V naught by R sine omega t. So V naught by R I can assume at I naught sine omega t. Check. Simple. This is the expression of the alternating current from here. You can see the voltage V naught sine omega t, current I naught sine omega t. Is there any phase difference between the current and voltage? No, there is no phase difference. You can observe that. You can whenever the pure resistance is there, and I'm just going to connect the resistance with a alternating voltage source, I can see that the current which is passing through that resistance, it is not going to have any phase difference with the input voltage. No phase difference. Okay, they are in the same direction. So just vectorically, if I draw the V vector, the I current is going to give the same direction this way, same direction. Simple. Okay. So now let us think. Just I'm going to have a I'm going to connect, instead of resistance, we're going to connect something else with this voltage source. So what is the thing? You can see I can have a coil. For an inductor, self-inductance, I'm going to have V is equal to V naught sine omega t. Like this. V is equal to V naught sine omega t. Now, what is the thing? Here also we can see the current is flowing through it, through the coil, through the inductor. The current is flowing. Now, some voltage has developed across the inductor, isn't it? So, what we can write? We already discussed VL is equal to inductor minus L di dt, isn't it? We know that thing. So, the voltage developed across the inductor coil is equal to minus L di by dt, is the thing. Now, see, according to Kirchhoff's law, we know the total voltage summation across the loop is equal to 0. So, this voltage plus this voltage, which is developed across this loop, summation is equal to 0. Kirchhoff's law. So, we can write it like this way: V plus VL is equal to 0. Kirchhoff's law. So, V, instead of V, we can write this one: V naught sine omega t. V naught sine omega t. And the VL, we can write it like this way: minus L di dt is equal to 0. No problem. Fine. So now, if I want to express, I'm just going to express what the thing, just you have to observe. Now see, V naught sine omega t is equal to L di dt, isn't it? So V naught omega t dt is equal to L di. Children, now observe that. I'm going to express the current because the mathematical form of the voltage is existing, but we require the mathematical form of the current, na? That form is here. So the both side I am going to do the integration. We are going to get the expression of the current, isn't it? So see, V naught. If I just going to do the sign integration, so what the result is going to come? Minus cos omega t omega equal to L into I plus something constant k. So like k plus V naught minus cos omega t by omega is equal to Li. So just again I'm just going to repeat that part. Li is equal to k minus of V naught by omega cos of omega t. Children, you see the expression of the current expression. There is a constant part is existing here. So constant current, how can I get the constant current? Unless and until there is a constant voltage source is there. Is there any battery cell is connected in the circuit? Because constant voltage source only will provide a constant current. No, there is no voltage source. Constant voltage source, just like a battery, just like a cell, is not connected here. So how can I expect that some portion of the constant current in the circuit is going to exist? No, that is not possible. So this k is 0. So we can write like this way. Li is equal to minus V naught by omega cos omega t. Therefore, just I can put the L down. I is equal to minus V naught by omega L cos omega t. The final expression of the current which is going to flow through this inductor coil whenever I am going to connect a alternating voltage source, sinusoidal alternating voltage source, just like this way. Tick, no problem. Acha. Now see, just like this cos omega t, just little bit just simplifications is required. Cos you can just like see sine. If I write a sine omega t minus pi by 2, what the thing is going to come? Omega t minus pi by 2. Just take the negative common. Sine, like I'm going to take the negative common, pi by 2 minus omega t, isn't it? So now negative of something, minus sine pi by 2 minus omega t. ठीक, ताले minus sine 90 minus theta, cos theta. Minus cos omega t, minus cos omega t, what I can write ultimately? Sine omega t minus pi by 2, isn't it? Understanding my point? So write the current final expression is equal to minus V naught by omega L. I need not require to just put this minus now, because finally we can write sine of omega t minus pi by 2. This is the final expression of the current whenever the inductor coil is connected with the alternating voltage source, sinusoidal alternating voltage source. This is the expression of the current. You can see that the voltage having sine omega t, but the current omega t minus pi by 2, the current is what? Current is lagging, voltage is leading. So we can just draw the vector diagram like this way. If I'm going to have the current in this direction I, and this is VL, anti-clockwise rotation, mane the voltage is when a voltage across the inductor is leading. Anti-clock rotation means leading condition. Clockwise rotation means lagging condition. So from the current I, just I am going to make a rotation anti-clock. So this is the VL, leading condition. The voltage is leading, just like current is lagging by pi by 2. Is it clear, children? Everyone clear or not? Any problem up to this point? I don't think so. It is having a problem. Now see, this sine is having no dimension. Sine something angle, no dimension. Voltage by something. Voltage by, we know the voltage by resistance is equal to current. Everyone knows. The voltage by resistance is equal to current. That everyone knows. Then what should be the like resistance like thing? Omega L. So voltage by something. So it is like resistance. But we are not going to tell this is a resistance. We will call omega L. It is called inductive reactance. What I am going to tell? Inductive reactance. Little bit just I'm reducing this shape. So, omega L is called inductive reactance. So now, many times we express the omega L XL, inductive reactance. Okay. So now it is XL is actually, instead of omega, what I can write? 2 pi FL. So L, self-inductance, it is a constant value because I'm not going to change the dimension of this inductor or the number of turns or anything else. So it is a fixed value, fixed geometrical structure. So L is a constant, but frequency, it is according to the value of the source frequency, it can be changed. So now you can observe that the frequency, with the frequency XL can be changed. So if the frequency is high, the XL is going to become very high. So high frequency AC, inductive reactance, it is going to become very high. So just like resistance, it is like a resistance. So if the frequency is high, the inductive reactance is high, it will stop the flow of the AC current. Simple thing. So high value, high frequency AC, just remember, high frequency AC is stopped by this coil, inductor coil.